Hello everyone, welcome back to the performance engineering session with Hands-on. In this today's session, we will be discussing about auto scaling in GCP. GCP, as most of us know, it is Google Cloud Platform. Before we get into the hands-on about auto scaling in GCP, let us try to understand a few basic concepts around auto scaling. So let us start with scaling. Basically, there are two types of scaling. First one is horizontal scaling and second one is vertical scaling. In case of horizontal scaling, basically we add additional nodes to the system, additional node or additional server instances or additional VM instances to the system. So in case of vertical scaling, we're going to add more power to the current machines. Basically, we try to add more resources to the existing system. Suppose if you have a number of CPUs 4, and if you find that there is a starvation on the CPU, then we are going to increase it by 4 to 5. So that's what vertical scaling. So third concept is auto scaling. So why it is auto scaling? Because whatever it is horizontal scaling or vertical scaling, we don't do it manually. Okay. So basically here we have a Google provider, cloud providers. Basically the cloud providers, they automatically add or remove the instances from the group, okay, based on the configurations, based on the set of what we do while deploy the applications. So that's why it is auto scaling. Another concept which is very related to the cloud is managed instance group. So as it names is, instance group means it is a group of instances or group of nodes. Why it is managed? Because here it helps us in auto scaling, auto healing, regional deployments, and automatic updates. Today's session, we will discuss about auto scaling and other topics like auto scaling, regional deployments, and automatic updates that we will see it in the subsequent sessions. The fourth concept is the load balancer. So most of us know the load balancer basically helps us to distribute the server among multiple servers. So when we have multiple server in a given system, so basically we need a mechanism wherein we need to distribute the load among multiple servers present in the system. So this is about the concepts. Now let us get into the GCP console and try to see how exactly auto scaling works. Okay, so here this is the instances page. So basically in this page we can see number of instances present in the given system. Okay, here we have a compute engine. Under compute engine we have so many options like VM instances, instance templates, and so on and so forth. Under VM instances, so this gives us number of instances present in the given system. So at this point of time we have only one instance and name of the instance is this. And also there are two types of IP addresses. It is external IP address and another one is internal IP address. So I mean, we will discuss these things in detail maybe in the subsequent session. Okay, so if you want to know what is the configurations of this Linux VM, maybe we can log into the Linux console basically, and we can understand what are the configurations. Okay, so this is, okay, we can log in here. So we are connecting to the Linux console for that particular instance, and we can try to understand what are the basic configurations of that particular server. Okay, so basically this is the machine. Okay. Okay, uname -a, this is the Linux command which gives us the details about the server. It is x86 family on 64-bit machine, and the server is Linux server, and this is name of the host. Okay. In order to know how many CPUs are there and what is the clock speed and other parameters, so this is the command CPU info. Basically, this command gives us details about the CPU. So here with this command, so we can see that there are two CPUs, CPU 0 and CPU 1, basically two CPUs. The clock speed of the CPU is 2.2 gigahertz, and other parameters like how many CPU cores are there, what is the cache size, and other parameters related to the CPUs can be seen with this command. Okay, so basically, this is the details about the VM instance that we have present here. Okay, so whenever auto scaling happens, so basically the GCP adds another instance of this type. Okay, so whatever software we have in this particular instance, so will be created when it creates another instance when auto scale happens. So this is about the instance. Second one is instance group. So as its name says, basically instance group contains a list of VM instances. At this point of time, so we have only one instance, and this is the name of the instance, and same thing we saw here. Okay, this is the external IP again for that particular instance, and this shows status of the instance. So as we see, it is LT now. Okay. So second parameter is auto scaling related information. So here we see min and max. So minimum is 1 and max is 10. So what min and max says here is min gives the min says that okay the minimum number of instances should be available in the system irrespective of the load. Okay. So basically the auto scale happens based on the load. At this point of time it is load. Otherwise, in this case study, it is load, and also we can do auto scaling based on other parameters as well. Okay, so and max is 10. So what happens? So as soon as we bring up the whole system, so the number of instances are available in the system is always one. Okay, so based on some criteria, GCP adds other instances to the system. So as per the criteria mentioned, okay, that criteria we will see. What is the criteria to add resources to the system? So we can define criteria in multiple ways. Okay. So for example, let us assume, so now minimum instances is 1. So and okay, let us understand what is the criteria. The criteria is okay, where is load balancer? Where do you find the criteria? 1 second. Yeah. So here we can see the criteria. Basically, in the load balancer, if you go to the instance group, there we can find the criteria to add or remove the resources. So what is the criteria here? We have is the target CPU utilization is 25%. Okay. So again, as I said, so we can also set the criteria with other parameters as well and other values as well. Okay. So it need not be 25%. Usually it will never be 25%. Because of the demo, we made it 25% so that it is easy to reproduce. Okay. That is the target CPU utilization. It means, so whenever CPU utilization on this particular instance becomes more than 25%, so GCP adds another instance to the system. Okay, when I say another instance, another similar instance to the system. So that is what here the target is. Okay. And coming back to the, then what is the criteria? Criteria is target CPU equal to 25%. Okay. Now, one moment we bring up this overall setup, we will have one VM instance. Okay, let us assume we generated load on this particular VM instance. Then what happens? There are chances that CPU utilization may go above 25%. Moment CPU utilization goes above 25%, what GCP does? GCP is going to add another instance to the system or another instance to this group. Then load balancer, here we have a load balancer. Load balancer will divert the traffic so to the new instance which is just created. So with that, what happens, the load will be distributed among instance 1 and instance 2, whereas instance 2 is newly created one. So that's how it works. So basically, this auto scaling works in a very similar way to the connection pooling in application servers, basically. Okay. So yeah, so even in application servers, so we will set minimum threads and max threads, and minimum threads is the one which always available in the system irrespective of the load. But as and when load is increases and all the threads in the connection pool becomes busy, and still if application server receives the load, then it is going to create another thread in the similar way here also. So we will have minimum threads equal to 1, and again based on some criteria. So if that criteria meets, then GCP adds another instance. Okay, so this addition of the resources may continue if a load on the instances present in the instance group, okay, reaches a CPU utilization more than 25%. Okay, that is the criteria set. So by the way, and it can go up to 10, okay, beyond which so it will not add up any resources in this type of auto scaling. By the way, there are different types of auto scaling. There are 3 types of auto scalings. Okay, this session we will be discussing about the dynamic auto scaling. Apart from dynamic, we have a predictive auto scaling and as well as scheduled auto scaling as well. So predictive and the scheduled auto scaling we will discuss in the subsequent sessions, but this session is in this session we will discuss only about the dynamic auto scaling. Okay, so this is how it works in the dynamic auto scaling. Okay, so another point, another area what we need to understand here is the dashboard. So basically here I have created one dashboard. So this dashboard basically monitors, this dashboard gives us a CPU utilization of all the servers in a given instance group. Okay, so we have one instance here. Okay, the name of the instance is it is 3958, and if you see here, so in 3958, the CPU utilization is around 0.77%. We have only one instance at this point of time. Okay. Now, basically what we do, we generate the load on the application and we monitor CPU utilization. So in this particular dashboard. So whenever we see CPU utilization goes above 20%, so we are expecting that GCP should add another node to the system, another node to the group. Okay, so this process should continue until either it reaches maximum number of nodes 10. So that is one condition. So otherwise the load on the system should become load on the system should be in such a way that a CPU utilization should not go behind 25% in any of the node given in the instance group. This is the condition. Okay, now as I said, basically and another part is this is the HTTP page. Okay, so in the VM instances, we have installed HTTP server, and this is the default page. Okay, so basically through Geometer script, we give this URL. Okay, we give the load balancer URL. So load balancer URL in turn routes traffic to the instances in the instance group, as we know, and here we are hitting this page basically. Okay, so when we get this particular page with multiple users, definitely there will be a load that will be generated on the instances in the group. Okay, so with that, there are chances that CPU utilization on that particular server may go above 25%. Okay, so once CPU utilization goes above 25%, so we are expecting that GCP should add another node to the instances. Here we should see another node to be added here. Okay, so and also when after it adds one instance, now total number of instances in this group becomes 2. Again, if CPU utilization on either of the node goes about 25%, what GCP does, again it adds another resources. And then what happens, this should become 3. Okay, as I said, this process continues until the number of nodes or number of VM instances in the system is 10, or the load be generating in such a way that CPU utilization should not go beyond 25% in any of the server. These are the two conditions where GCP will not add any resources to the group. Okay, as we know, this is the Geometer. By the way, as we know, as most of us know, Geometer is the load generation tool, and it can be used to generate the load on the applications. So as I said, we are generating basically we are hitting the load balancer, and which in turn it's the VM instances, and those instances we have installed HTTP server, and so we are trying to load the default web page on hitting the hitting the IP address of the HTTP server. Okay, that's how it is. And also, if you see here, we are continuously increasing the load. For example, it will start with the 400. Okay, it will start with 400. After 5 minutes, so we are going to increase the users by 200. So basically, this gives us the incremental in the user load. So why we have designed the load generation in this fashion is to see that, okay, under which load CPU utilization on the servers goes about 25%, maybe at this point of time. So it may create 2 instances. Again, if you further increase with this, maybe in one of the VM instance, CPU utilization may go above 25%. What happens again? GCP creates another instance. Maybe for this particular load, CPU utilization on those 3 instances may be less than 25%. Maybe at this point again, CPU utilization may go about 25%. Again, this process will continue. We are trying to analyze that particular behavior. Okay, that's one point. Another one is, as we said, in case of auto scaling, it is not only adding up the resources, it is also removing the resources. Okay, so when it adds the resources, whenever that criteria meets, it adds the resources. And when it is going to remove the resources, when that criteria doesn't meet in all the instances for a given cooling period. Suppose if cooling period is 5 minutes, okay, and the target CPU 25%, whichever we have set, is less than 25% for 5 minutes, then it tries to remove one instance and see how exactly it works out. Okay, so that's how it goes. Okay, so after we remove one instances, if CPU utilization is again less than 20%, so again it tries to remove another instance as well. So basically, as and when there is a load, so it adds up the resources, and when there is no load, it also removes the instances. Okay, so that's how basically this works. Okay, and that we try to see how exactly it works now. Okay, let us generate the load and see how system behaves. So here we're generating the load. Response time is around some 1 second to load that particular page, and we don't have any errors. Okay, so as we know, basically, as I said, we are going to monitor. So what is the CPU utilization of this particular server? And we are expecting GCP to add other instances when CPU utilization goes above 25%. Okay, so that is the point. And another point is what I observed was maybe because of a delay. Okay, maybe this year it may not refresh the data immediately. There may be a lag in the what is the actual CPU utilization and what it will show on the dashboard. So because of that delay, we may see the instances here, and still the CPU utilization may not shown about 25%. That may happen. So basically that's because of the delay, but there will not be any lag in the GCP to add the resources versus what is the CPU utilization. That we don't see any lag or delay, but here we may see the delay. Okay. Okay, so here let us see whether it added any instances to the instance group. Okay. Okay, not sure what happened. Okay. Sorry, we are not able to fulfill the request. This is some error, but we don't see any errors as such. Yeah, so if you see, it created 3 instances. Okay, this is the instance group. It created 3 instances. Again, here in the screen, the CPU utilization still it shows less than 1%. Okay, there must be a lag in the dashboard and the actual CPU utilization. Okay, so if we refresh here. Yeah, so here we can see 3 instances. Okay, still it is showing a CPU utilization of 1 instance. Okay, still it has to load CPU instances utilizations of these instances. Okay, as I said, there must be a lag. Okay, so if you see here, it is 450. Okay, there's a 2 minutes lag. If you see, the actual time is 4:52, and whatever resources we can see is 2 minutes behind. Okay, so that's how it is. So that should not be a problem. Let it be like this for now. See, and one more thing is, looks like even after adding 2 more instances, okay, what is the user load? User load is still 400. Okay, yeah. So it added 1 more resource. Okay, so basically after it adds 2 instances, definitely in one of the instance CPU utilization might have gone more than 25%. For that reason, it is added another instance here. Okay, now in total we have 4 instances now. Okay. Yeah, you can see here. Okay, so basically you can see in one of the server the CPU utilization gone above 60%, but our criteria was 25%. Okay, so maybe I think we can stop the test. Okay, so let me stop the test now. So basically what we observed was, before we started the test, we had only 1 instance, and CPU utilization was less than 1%. And also we have verified what is the auto scaling criteria. Criteria was the target CPU is 25%. Okay. Then we generated the load using a Geometer. Okay, basically we are trying to hit HTTP server. So as and when load is increased, we observed that CPU utilization on the instances went above 25%. Okay, with that, so as per the auto scaling policy, GCP added other instances to the system. Okay, now okay, this is how it adds resources to the system. Okay, so again, after we saw 4 instances in the GCP, we have stopped the test. Okay, now it is a cooling period kind of a thing. Now what happens after we remove the after we stop the load on the system? Definitely CPU utilization should have come down below 25%. Okay, but GCP doesn't remove the instances immediately after it doesn't see the utilizations less than 25%. Okay, it will wait for a cooling period of time. So whatever cooling period it had set, okay, it will wait for those milliseconds or minute. Okay, if none of the utilizations of any instance goes above 25% during that period, so then it is going to remove one instance from the group. Okay, again same experiments continues. Okay, again it will wait for cooling period to see if again utilizations are less than whatever target we had set. If still it is there, what happens? Again it's going to remove other instances. Okay, this will continue, and if you wait for maybe 2-3 minutes, okay, we can see that number of instances in the instance group becomes 1. Okay, so it will take some time. So for now I'll pause the video, and let us resume this after maybe a couple of minutes to see that how GCP removes the instances when there is no load on the in-realm instances. Yeah, if you observe here, we see these are the 2 instances are being deleted. If you see here, instance is being deleted. And also, if you see here, this is also indication that instance is being deleted. So it means, as I said, it continuously monitor, and it tries to delete the resources whenever it doesn't, whenever there is no significant load on the system. Okay, that's how it works, by the way. Okay, so thank you very much for watching this video. By the way, if you wait for another few minutes, maybe couple of minutes, we can see that there will be only one instance in the group. Okay, so and also if you see here, okay, now if you see, there were 4 instances. If you remember, there are 4 instances, but uh, 4 instances, but we don't see any load on one of the instance. We can see some load is there on first 3 instances, 34, 30, and 26%. And in the other instance, there is no load at all. Okay, so that's how it works. So basically, what we have done, so when we started this, we have seen, we saw only one instance in the instance group and utilization was less than 1%. Then using Geometer, we generated the load. So CPU utilization on the instances went above 25%. So as per the auto scaling policy, it added a few instances to the group. Okay, so number of instances increased to 4 at some point of time. Okay, so then what we have done, we stopped the load to be generated on the application. So since there is no load on the server, utilizations on the instances has come down. With that, we can see there is a trigger, I mean, there is a notification kind of a thing wherein GCP is showing this instance will be deleted. Okay, thank you very much for watching this video. In the subsequent sessions, we will discuss about other these other scaling policies, and let us see how exactly those policies works and what are the advantages of those policies and all. Okay, thank you very much for watching this video.